Hello, my name is Mundo. I am an industrial engineering student at Paragon International University. And the content of this video is basically related to the Physics 131 crash course final online assessment exam. And the topic that we picked to discuss today is the elastic collision and the inelastic collision. So before getting to know that concept, so you must have heard of the people bump into each other or ball on the pool table, they clash or they collide each other. And that terminology create a word which is called the collision. But by the definition physically, it's defined as when two objects in a motion collide or have contact with each other. With this knowledge in mind, we can get started and head into the elastic collision. So, the elastic collision is defined as when two objects in the motion have contact and then they separate after. To clarify this definition, we have figure to explain. We assume that before the collision, we have the object A, which has the mass of ma, and also it has the velocity of the va1. And assume that we also have object B, have the mass of mv and also the velocity of vb1. And the object A travels to the positive direction and the object B travels to the negative direction. And as you can see here, it is during the collision, it clash or collide. And after the collision, there is a noticeable change, which is the va1 right here transform into va2. And the VB1 right here transform into VB2. And you must have wondered what is the special characteristic of this elastic collision. The special characteristic of this elastic collision is that the kinetic energy is conserved. As you can see right here, the kinetic energy of object A plus the kinetic energy of object B equal to the kinetic energy of object A after collide plus the kinetic energy of object B after collide. And here is the formula, the general formula of the kinetic energy. So not only that the kinetic energy is conserved, it's the momentum as well as the kinetic energy is also conserved. And we have the expression that the momentum of object A plus momentum of an object B before collision equal to the momentum of object A after collision plus the momentum of the object B after collision. And not only that the momentum conserved for the elastic collision, it's also as well conserved for the inelastic collision as well, which we will discuss later in the video. So the reason why the momentum is conserved is because that let's assume that the object B after the collision. So the momentum is a vector. The vector we have for this direction and this direction is cancelled out, and this direction with this direction cancelled out. So that means that the total momentum is equal to 0. To improve the understanding, we also have exercise in relation to this concept.
Let's look at the example. The example wants to calculate the velocity of two objects after the collision. And we have m1 equal to 0.5 kg, m2 equal to 3.5 kg, and v1 equal to 4 meters per second, and v2 equal to 0. Let's look at the solution. We know that in relation to the elastic collision, the two conservations occur. The first conservation is the conservation of kinetic energy, which is the equation 1 represent its equation. And the second case is the conservation of momentum, which is the equation 2 represent its equation. And from the equation 1, after a quick equation multiplication, we get mb multiplied by vb to x squared equal to ma factor VA1x minus VA2x factor VA1x plus VA2x, which is the equation 3. And from the equation 2, also after a quick equation multiplication, we get MB multiply VB2x equal to MA factor VA1x minus VA2x. As we get the equation 3 and 4, we divide the equation 3 by the equation 4. And then we get the equation 5, which is VB2x equal to VA1x minus VA2x. As we get the equation 5, we plug it to the equation 4. And after the equation calculation, we get VA2x equal to MA minus MB factor VA1x divided by MA plus MB, which is the equation 6. And we plug the equation 6 back to the equation 5, we get VB2x equal to 2MA multiplied by VA1x divided by MA plus MB. So, after we get what we really want, which is the equation to calculate the VA2x and the VB2x, we plug all the number that we got from the exercise in, which we get VA2x equal to minus meter per second and VB2x equal to 1 meter per second. You also must have noticed that why VA2x equal to minus. Well, that interpret as the VA2x go to the negative direction after the collision, and the VB2x of the object B go to the positive direction. This is it for the elastic collision part.